You know, it's really incredible how quickly things are moving with electric vehicles. Not long ago, they felt like, well, kind of a niche thing. But now there's this massive global push.
It's huge.
Countries are setting dates for phasing out gas cars, and you see more and more EVs on the road every single day. It's not just talk. The electric future is definitely, well, it's here.
Absolutely. And what's truly fascinating, I think, is the immense undertaking behind making this transition happen, especially when you look at how these vehicles are actually manufactured.
Right.
It's a whole new ballgame compared to traditional car making.
Exactly. And that's what we're diving into today. We've got some really compelling information from Iscar, a company that's right at the forefront of cutting tool technology. We're going to explore the intricate world of advanced metalworking solutions specifically designed for electric vehicle manufacturing.
Yeah, our goal really is to shed light on the unique manufacturing puzzles that come with EVs. I mean, think about the sheer size and complexity of battery housings,
Huge things.
the precision needed for electric motors, and the crucial need for lightweight materials in the chassis. And, well, to understand how Iscar is tackling these challenges with some seriously innovative tools and techniques.
So consider this your inside look at how the EV revolution is being built, piece by incredibly precise piece. We're going to uncover why building these vehicles is so different from what we're used to, and highlight the absolutely vital role that super accurate metalworking plays in making it all happen. There are some genuinely surprising details in here, I think.
Let's begin by looking at the broader context. This move towards electric vehicles isn't just about, swapping out a gasoline engine for a battery.
No.
It signifies a fundamental shift toward greater energy efficiency, a real commitment to sustainability, and of course, the pursuit of high-performance driving.
Right. And this fundamental shift has a direct knock-on effect on how these cars are actually put together. We're not dealing with the same old engine blocks and exhaust systems.
Not at all.
Instead, we have a completely new set of key components, each with its own very specific and often tricky manufacturing requirements.
Precisely. Let's take battery housings as a prime example. To maximize the driving range and overall efficiency of an EV, these housings need to be as light as possible.
Makes sense.
So this often means using materials like aluminum and advanced composites. Now, while these materials are fantastic for saving weight, they present some real, let's say, headaches when it comes to machining them. We're talking about complex shapes and designs that often demand very sophisticated milling techniques.
So it's not just a matter of, bending some sheet metal into a box.
Oh, not at all. The level of accuracy required is incredibly high, and you're often working with materials that can be quite finicky to handle.
Okay.
Then you move on to the electric motors themselves. These involve numerous cylindrical parts that need extremely precise turning operations to ensure they run smoothly and efficiently, delivering that instant torque EVs are known for.
And then we have the ongoing drive to make the entire vehicle lighter.
Yeah.
We're seeing more and more aluminum and composite materials being used in the chassis, too.
Yep.
I can only imagine that presents a whole new set of challenges for the people doing the machining.
You're exactly right. Machining aluminum and composites requires specialized tools and very specific techniques to achieve the necessary strength and structural integrity while keeping the overall weight down. It's a delicate balancing act.
So we have these new and demanding manufacturing requirements. Now, how is a company like Iscar tackling these head-on? Our information tells us they have a long history in the cutting tool industry and a real focus on coming up with innovative solutions.
Well, what's really interesting about Iscar is their comprehensive approach. They're not just focused on making, say, a slightly better drill bit.
Right.
They're looking at the entire machining process. This involves using advanced materials in the construction of their tools, employing incredibly precise engineering in their design, and leveraging the latest technologies to, boost how quickly parts can be made, keep production costs under control, and ensure consistently high quality. Their research and development teams are constantly exploring the best ways to machine different materials for a wide range of applications, whether it's creating a perfectly round hole, shaping a complex curve, or achieving an ultra-smooth surface finish.
And they have some specific examples of their tooling that are particularly relevant to EV manufacturing, right? Let's start with milling. It sounds like they're really utilizing advanced materials like PCD polycrystalline diamond.
Precisely. Tools and inserts tipped with PCD are a real step forward in milling. They offer significantly faster cycle times, meaning that those crucial EV components can be produced much more quickly.
Faster production.
Think of it like using a super sharp, really long-lasting blade. You can get the job done faster and with better results. Plus, PCD delivers a superior surface finish and overall performance, which is absolutely essential for components like those intricate battery housings and lightweight chassis parts we discussed earlier.
Okay. And they've developed something called multi-master interchangeable solid carbide heads specifically for machining aluminum. That sounds pretty smart.
It is quite clever, yeah.
Yeah.
The real benefit here is their versatility. You can use these for both roughing, which is the initial stage of removing a lot of material quick.
Taking the bulk off.
Exactly. And finishing, where you achieve that smooth, precise final shape. The 4 polished flutes, those are the channels that run along the cutting head, are specifically designed to efficiently clear away the aluminum chips as they're created. This is critical because aluminum chips can be quite sticky and can interfere with the machining process. The polished flutes also help to minimize vibration or chatter, which can lead to a poor surface finish.
Right.
And the interchangeable heads mean you can swap out a worn tool quickly without having to reset the entire setup, saving valuable production time.
Less downtime on the factory floor is always a huge win. Always. What about those indexable milling tools they mentioned?
These are engineered for high-efficiency material removal. The key advantages here are the excellent surface finish they can achieve and their extended lifespan.
Longer lasting.
Yeah, this is particularly important when manufacturing critical EV components where both precision and long-term reliability are absolutely vital.
Moving on to turning. It seems they offer a wide variety of indexable isotype inserts and tool holders. What's the significance of that?
Well, these provide optimal performance in turning operations, which, as we discussed, are crucial for creating the highly precise cylindrical parts found in electric motors.
Right, the motor parts.
The sheer variety of insert shapes and materials allows manufacturers to sort of fine-tune the cutting action for different types of materials and very specific manufacturing requirements.
Now, this rotor challenge sounded particularly interesting. Machining those stacked electric steel plates. It sounds like a real headache.
It really highlights some of the very specific and unique demands of EV manufacturing. Because of how electric motors function, you actually can't use traditional coolants when machining these rotor plates.
No coolant. Yeah.
No coolant. The surface needs to be absolutely clean. No stray metal chips, no oil, no water, just air, basically. But the machining process itself generates a significant amount of heat.
Of course.
And the small fragmented metal chips have a tendency to stick to the surface. All of this needs to be managed while also achieving a very strict and smooth surface finish. It's tricky.
So how did Iscar manage to solve that tricky problem? That sounds tough.
They developed a really innovative tool design. It incorporates coolant holes, but they're designed for air, not just at the bottom of the tool, but also directed right at the cutting edge from the top.
Ah, clever.
This allows for effective cooling using just compressed air and helps to blow away those problematic chips before they can stick. They even use 2 round cutting inserts in sequence 1 to take a semi-finish cut and then a second to achieve that very smooth raw 1.9 surface roughness.
RAP 1.9, that's incredibly smooth.
It's an incredibly fine finish, yeah. Essential for the efficient operation of the motor.
That's some serious engineering problem solving right there.
Wow.
They also mentioned their Alu P-turn tools for high volume production. What's special about those?
The Alu P-turn is all about providing robust performance and enhanced control over the metal chips that are produced. In a high-volume manufacturing environment, you need tools that can consistently deliver quality and efficiency.
Reliability is key.
And that's precisely what this line is designed to do. Good chip control is vital for preventing interruptions and ensuring a smooth production flow.
Makes sense. They also cover parting, grooving, and threading with their cut T-grip and self-grip tools. It sounds like they're providing solutions for pretty much every aspect of EV assembly.
Exactly. These tools are engineered for both versatility and reliability, allowing manufacturers to create the intricate thread profiles and grooves that are necessary when putting all the components of an EV together.
All those little details.
And their Tang grip system is specifically designed to provide strong clamping stability and allow for quick setup times when performing grooving operations, again, emphasizing the need for efficiency in production.
And then there are the multi-function tools.
Yeah.
I always like the sound of anything that can combine multiple machining steps and reduce the overall cycle time.
Oh, absolutely. In manufacturing, time is, well, it's a critical factor. Tools that can perform several different machining tasks in a single operation can significantly boost overall productivity and reduce the time it takes to produce each part. Huge advantage.
Moving on to creating holes, their SumaCam modular drills sound quite interesting. with those exchangeable solid carbide heads.
Yeah, the SIMACAM system is a great example of intelligent design because it allows for quick and easy replacement of the drill heads. If a head wears out or if you need a drill of a different diameter, you can swap it out in, a matter of seconds.
Minimizes downtime.
Exactly. Minimizes downtime. The ICN heads feature a very sharp cutting edge, which is ideal for certain materials, while the ICG heads incorporate a chip splitter that helps to break up the chips for more effective removal, especially when drilling deeper holes.
Different heads for different jobs.
Precisely. Overall, the SIMACAM system offers high drilling speeds, or penetration rates, and efficient chip evacuation, both crucial for efficient manufacturing.
And for achieving even more precise holes, they have the Bay-O-T ream reamers with those customizable PCD tips.
Yes, for high-speed reaming of aluminum automotive components, these customized PCD tips ensure exceptional accuracy and a very high-quality surface finish. What's particularly clever, I think, is the inclusion of RMBN RC ring adjustment rings.
Adjustment rings. What do they do?
These rings help to eliminate the problem of tool runout. That's a slight wobble or eccentricity in the rotating tool.
I see.
Runout can be caused by tiny imperfections in the machine's spindle or even the weight of a long tool, especially in horizontal machining setups. By providing a way to fine-tune the concentricity, these rings ensure a more precise and accurate hole.
Clever.
And the fact that a single tool holder, like the RMBN7 they mentioned, can accommodate a range of different diameter reaming heads in this case, from 16 to 20 millimeters, also adds a lot of flexibility and reduces the number of different tools a manufacturer needs to keep on hand.
Versatile, too.
Yeah.
And to top it all off, they're utilizing advanced coatings like diamond-like carbon. What's the advantage of those?
These advanced coatings, they basically enable the tools to be used at higher cutting speeds and significantly extend their lifespan, particularly when machining abrasive materials like aluminum and other non-ferrous metals.
So faster work, tools last longer.
Right. This directly translates into lower tooling costs for manufacturers and increased overall production efficiency. Big benefits.
It's really quite amazing how much intricate engineering goes into the design of these seemingly simple cutting tools. They even mentioned using finite element method, SEM analysis, in their design process.
Yes, this is where they apply sophisticated computer modeling to really understand the science behind the cutting process. By using FEM, they can simulate the entire machining operation, analyzing factors like the forces involved, how the tool flexes under pressure, its natural vibration frequencies to prevent chatter, and even how the metal chips flow away from the cutting edge.
So they can see how it will work before they make it?
Essentially, yes. This allows them to optimize their tool designs for maximum performance and to identify and address potential issues even before a physical prototype is ever built.
So it's far more than just shaping a hard piece of metal. It's a very sophisticated and science-driven engineering process. Really impressive.
It absolutely is.
Now, looking beyond just the tools themselves, it sounds like Iscar is also placing a strong emphasis on sustainability and working very closely with the manufacturers they supply.
That's a really crucial point. Iscar is committed to sustainable manufacturing practices by designing tools that minimize material waste during the machining process, reduce the energy required for cutting, and improve the overall efficiency of production.
Good to hear.
This aligns perfectly with the broader environmental goals of the electric vehicle industry itself.
And it's not just a simple customer-supplier relationship, is it? They emphasize their engineers working directly with the manufacturing teams.
Exactly. They see themselves as a genuine partner in the EV revolution. Their engineers work in close collaboration with the manufacturing companies to gain a deep understanding of their specific needs and the challenges they're facing.
A real partnership.
Yeah, this allows them to provide truly tailored tooling solutions and ongoing technical support. This collaborative approach is essential for ensuring that EV manufacturers can achieve their targets for efficiency, quality, and continued innovation in their production processes.
So it sounds like Iscar isn't just selling a product. They're providing expertise and playing an active role in driving the entire electric vehicle manufacturing sector towards a cleaner and more efficient future.
Precisely. As the demand for electric vehicles continues its rapid and, frankly, significant growth, companies like Iscar, with their strong commitment to both innovation and collaboration, will be absolutely vital in enabling that growth and ensuring it's done in a sustainable way.
Okay, let's wrap up our deep dive then. We've seen how the rapid shift to electric vehicles has brought about a completely new set of manufacturing challenges, particularly when it comes to working with lightweight materials and creating complex components like the large battery housings and the precisely engineered electric motors. We've also explored how Iscar, a real leader in cutting tool technology, is meeting these demands head-on with a wide array of advanced metalworking solutions, from incredibly hard PCD-sipped milling tools to innovative designs for that tricky task of machining electric motor rotors, all while keeping a close eye on both efficiency and sustainability.
Yeah, the key takeaway here, I think, is that the electric vehicle revolution isn't solely about advancements in battery technology and the development of charging infrastructure, although those are huge.
Absolutely.
It's also deeply interconnected with progress in manufacturing processes and the sophisticated tools that make it all possible. Companies like Iscar are, in many ways, the unsung heroes of this transition, constantly innovating behind the scenes to help bring these vehicles to life with the extreme precision and high quality that's required.
Okay, so here's where it gets really interesting. Considering the sheer complexity and the incredibly precise metalworking processes involved in creating just one electric vehicle, what might be the next major leap in manufacturing innovation needed to truly scale this industry across the globe and make it even more environmentally responsible? Could we see entirely new manufacturing methods emerging that go beyond even the advanced cutting techniques we've discussed today? Just something for you to really think about.